Afternoon. We'll be getting ready to start panel 4 on space situational awareness and space traffic management. This is the traditional process where, since I hold up the microphone, I have enough technology to overpower anyone in the room. So just begin talking. So first of all, thank you everyone for hanging in. This has been a great day. A lot of really interesting topics have been going on, and really we're just only really touching the surface of several of them. And I know conversations are continuing outside, which is one of the most valuable parts, I think, of these conferences. The panel we have here today, a great group of people on, representing a mixture of both commercial and government, as well as U.S. and international perspectives, which is reflective of the nature of space situational awareness now today anyway. To my left, Travis Langster, the Vice President for Analytical Graphics. Beyond that, Professor Kazuto Suzuki, a longtime friend. He's a professor up at Hokkaido University in Japan, and we've worked on Japan issues for a long time together. Bhavya Lal is a research staff member of Institute for Defense Analysis, Science and Technology Policy Institute, and I'm proud to say a PhD graduate of the Trachtenberg School of Public Policy and Public Administration, so we're go Colonials. Next to her, Colonel Gerard Leboué, the Air Attaché from the Embassy of France. We're particularly honored to have him here with us today. And at the end is Klaus Hansen from the European Space Agency, who has a long involvement in legal matters. I think we overlapped a little bit in the Galileo discussions. Sort of look familiar? We all did. We all spent time in those discussions. But with that, I'd like to have each of our panelists do about 5 minutes or so, introducing to their perspective, where they're coming from, what they see as the most important issues that should be discussed and thought about in space traffic management and space situational awareness. And then we will shift over into more of a Q&A and discussion session. And I have a series of embarrassing and difficult questions to ask if I think the audience is lagging. So. With that, I will turn to Travis.
Thank you very much. Just to reintroduce myself in AGI's perspective in space situational awareness and space traffic management. We come at it from a commercial industry perspective, though we are partners with government, military, international, commercial, and civil as well. At our core, we're a commercial software company, but we've seen a significant growth in the market demand for commercial SSA services. And about 4 years ago, we stood up what we call the Commercial Space Operations Center, or ComSpot. And we stood that up. Actually, a predecessor to that was supporting the Space Data Center, which is a commercial consortium stood up by the Space Data Association, which was stood up in the absence of exquisite information such that commercial owner-operators could make timely and actionable decisions about safety of flight. So pursuant to that, we stood up the ComSpot. Because of the growth, the continued market demand for services and capabilities that grew beyond the free service that the Air Force provides through spacetrack.org, which has been an incredibly valuable service throughout the years and a really needed service. However, today's space environment is much more dynamic. Things that are maneuvering are sometimes by design, sometimes potentially provocative, or other descriptors that have been used for those. And the timeliness and the accuracy needed to understand the space environment, not to mention the growth of debris and the number of objects just in space. We had the launch providers up. The number of satellites that they will be launching over the next 10 years dwarfs the number of launches in the previous 30 plus years. So our perspective is not to take over or take on anyone's particular mission, but to augment and enhance any services that exist today, where there is a need to provide commercial SSA services that are not being provided today for those operators or other areas where those services are needed, to take those on. And we have been doing that over the last 4 years. We have the customers that we have serviced in this domain include international, U.S. government, military, commercial, and so the service we're providing is an operational capability today. So from a viability perspective in terms of the marketplace, the viability is there. We see the growth only continuing, not only in the commercial realm, but also the government, military, and international. We also see it is very connected between the government, military, and commercial marketplaces. As I said, government has been providing that free service as of today, and in some cases a much more exquisite capability is needed. And there's lots of conversation on how to potentially offload that international free service that is inherently non-military in terms of what's now known as space traffic management. So that's the perspective that we come at this, and I'll be prepared to address any questions, any further details.
Okay, thank you.
All right. I think my role here is to discuss about the perspective, Japanese perspective, and how we see the SSA and the space traffic management. First of all, when the issue of the SSA was brought up in the context of the Japan-US space cooperation, there's been a big debate about, in Japan, who's going to be responsible for doing what. And there has been a problem in Japan that the Ministry of Defense was for a long time being excluded from the space policy, not just for the development of technology or the ownership and operation of the space capabilities, but also the use of the space assets. So there were, to make a long story short, the Ministry of Defense doesn't have the capabilities to get involved in SSA. So there were questions about whether to involve the JAXA, the civilian agency, in the SSA, which is basically operated by the US military. So there has been a sort of a gap in between the civil military issue between Japan and the United States, and fantastically enough, this was a sort of a harbinger to include the SSA network, the civilian agency in the SSA network. So the JAXA is taking a part of the responsibility of the SSA, upgrading the radar and optical telescope in the Okayama prefecture. And this is the sort of one step beyond the improvement of the SSA international network, and I think that was the sort of a thing that Japan has played a certain role in the sort of reconfiguration of the SSA international network. I think the role of Japan, as geographically speaking, is very important because Japan is strategically located in a very rough neighborhood. And this is where there is no SSN radars or optical monitoring capabilities, and Japan provide perfectly well to cover the Western Pacific and the eastern side of the Eurasian continent, which of course includes the China and North Korea. So I think the Japanese installations of the radar and optical capability in Okayama Prefecture will provide a very important information about what's going on in the areas above the Chinese continent and the Korean Peninsula. I think this would provide more higher quality attribution of anything happening in the low Earth orbit as well as middle MEO. And I think this attribution issue is the key element of improving the quality of SSA. And I think the Japanese telescope and radar has not yet disclosed its its technical capability, but as a member of the National Space Policy Committee on the space security side, I cannot disclose the details, but I think the Japanese SSA capability will provide enough information for to understand what is going on about the area of Western Pacific and the eastern side of the Eurasian continent. In terms of the space traffic management, Japan has not been coming yet to discuss about the space traffic management, but there are increasing number of the commercial venture is appearing in Japan, and these venture involves the small-sat constellation, and they are also they need the they recognize the importance of the space traffic management. So I think we are yet to begin the discussion, but I think Japan is now being well. I think Japan is the ground is getting fertile to discuss about the space traffic management.
Okay, thank you.
So I'd like to touch on 3 points briefly. The first one is, and I think this is something that we've discussed throughout the day, so I don't need to belabor it, that DoD really needs to and would prefer to focus on its core goal of space defense protection, and is overwhelmed and likely to be even more overwhelmed by civil and commercial needs. Just to put a little bit of number on that, of the 300 or so organizations that the 18th Space Squadron provides space safety services to, only about 10% are DoD or non-US military related. Almost 90% of the organizations they support are academics, commercial, and others. So I think that's something to remember. Another point on that front is that while operators are happy to receive the information they get for free, some of it is just publicly available on a website, and some of it, you sign, special agreements with DoD, and you get, special accesses. But on the whole, they need to have a level of service that DoD cannot and potentially
if that
should not be given. So there really is a need to have a civil-oriented SSA service provision. The second point I want to emphasize is that in addition to the challenges DoD would have in the future, the number of entities that will be operating in space, I mean, it's a staggering number. Where CIMA, I saw, the Euroconsult report talked about 3,600 small satellites being launched in the next decade or so, and that doesn't even include the SpaceX constellation, whose numbers just keep growing, by thousands each time they do an FCC filing, or Boeing. So the number of entities that any organization would need to track is just extraordinary. Already today, I think DoD sends about 200 conjunction warning messages, emails a week, and there's this challenge that when all these operators get these notices, they start to ignore them because they don't know which ones are more important versus less. And with a single constellation, and I think this was an ESA study, a single LEO constellation would increase the number of warnings by a factor of 70. And with CubeSats going up, again, the studies differ by how much. There could be millions of conjunction warnings, and everybody starts to ignore them, and then you start to get into different sorts of problems. So that's sort of the trend on the demand side. On the supply side, consistent with what Travis said, in a study that we recently did, there's 12 companies that we know of, and this study is already a few months old, that are able to provide a lot of the services on the sensor side, on the software side, on the dissemination side. 3 of them can do the entire gamut of operations. So the commercial supply side is starting to provide something that was only in the province of governments. Third and last, and I think I'm running out of time, again in the study that we did, we looked at what a future SSA system could look like, and turns out there isn't really one option. There's lots of different ways you can go forward. DoD could continue to do things, and the strength there is that continuity of operation, Not, maybe it won't cost a whole lot. The downside is DoD can't add sensors, non-standardized sensors. Their sensors have a very high bar for reliability. And again, so the alternative would be, could a civil entity like Office of Commercial Space Transportation at FAA or Department of Transportation provide the service? And of course, another advantage of that would be, in the context of this conference, it provides redundancy, a second system in case there are issues with the DoD system. The downside of that is obviously there's some amount of replication and there's a cost to it. Third option is industry does it themselves. I mean, we heard this morning about SDA, companies banding together and providing, sharing information. Upside is, self-provision, no cost to government. Although, if something goes wrong, taxpayers will be required to come step in and clean up the mess like we did with the auto industry, right? So there is no free lunch. And there's a downside that, there are going to be some companies that won't be able to afford the services that, AGI and others offer. And then last but not least, there's the international option, although I think that's putting the cart before the horse because you need to have the national policies kind of resolved and settled, even as you're having international discussions before you can move to an international regime. And I can get into any of the details.
Okay, very good. Colonel?
Okay. I'd like to give you a military perspective, or more exactly a French Ministry of Defense perspective on SSA. For a country like France, SSA is a necessity. It's not a nice to have, it's a need to have. There are several reasons for that. First one is we have national security space assets, like some other countries, not as many as the US, obviously, but we do have some, so we need to understand what's going on around them and how to safely launch them. We also have agreements with other allies and partners on using their space capabilities, whether it's MILSATCOM or imagery. So we are concerned about the protection of our allies' space assets. And we are also an active participant in the European space policy, so that's a part of it. And as we know, we host the European spaceport in French Guiana, so obviously everything that goes to space, ways to deconflict, access to orbits are interest for us. So SSA is key to make informed decisions about space and space policy and space military policy in general. So that's why we feel compelled as a Ministry of Defense to have SSA assets and to contribute to what we call a recognized space picture. That's the military term for a product of what SSA delivers. So an RSP, when we use SSA in France, awareness means knowledge in French. It's closer to knowledge than to awareness, meaning in English, I would say. So the RSP, the localized space picture, captures the meaning better from a military standpoint. It's a representation of what is going on in space, what is coming from space, and what is going to space. It's the fusion of all the sensors that we have to monitor space objects in low Earth orbit or geo orbits. And it also fuses all the intelligent information on space, through space and on Earth, focusing on our space capabilities. So to do that, 6 years ago, that was the main driver behind the creation of a French MOD Joint Space Command, SSA, and building a RSP was the primary driver. So it's 6 years old, it's fairly new, and we have been able to build an effective RSP only for 1 year now. So it's still under a work in progress. So that RSP building drives to set up procedures and synchronizations of our space surveillance assets. We have a center dedicated to that. It's called the Cosmos. It's located in Lyon. And it runs basically our space surveillance assets, our radars, surveillance radars called the GRAV, and our trajectory radars called SATAM, that monitor traffic in low Earth orbits. And we are also acquiring a new capability to monitor geo traffic, a geosensor capability. So we hope we'll be able to fuse all that in an RSP by the end of the year. And we work, so our Cosmos unit and our Joint Space Center work also very closely with the equivalent of Defense Intelligence Agency. Because building an RSP using these radars is not enough to build an assessment. It basically is just like watching small white little dots moving around. If you don't know what those little dots are, what's their connections, what's their capabilities, what are they are designed to do, how they relate to each other when you talk about the constellations of satellites, you really cannot understand what's going on in space. So that's why we also work with our intelligence agencies to build a threat space picture. So understanding what are the threats to our assets and to our allies' assets. And on top of that, the picture would not be complete if you didn't have also a way to monitor. I'm a pilot by trade, so it's exactly like when you fly as a pilot, you need weather and you need deconfliction with other traffic. So you need to build a picture of debris and space weather. That's what we call the SERP, the Space Environmental Risks picture. So when you have these RSPs, TSP, and SERP, then you have good space situational awareness, and then you can make informed decisions regarding policy and strategy for the military. So the Joint Space Command, especially the Space Center that we just built, have an overarching task to build and analyze and assess space situation by fusing all these elements. It's also the key node where we plug the information we get from partners. We cannot do it on our own. We have limited space surveillance assets. So building agreements with partners that have similar capabilities is key. And this Space Operations Center that we have is where we get feeds from JSPOC, talking about our US allies, or cooperation bilateral agreements that we have on space domain awareness with the US. And I cannot emphasize enough the importance of building these data sharing agreements. They are instrumental in building an effective RSP, but also on making sure that we have a common understanding among allies and partners about how to protect our respective data and how to protect maybe classified assets that we have in space and I want everybody to know about. So this data protection is as important as the space surveillance awareness piece of the only space surveillance awareness piece of it. And in that domain, I would say that last Friday, I read an op-ed in Washington Post about space policy, and it said that the US is even wary of sharing space secrets than its communication intelligence. And I would tend to disagree. I mean, to some extent, we have found in the US, I'm focusing in the US in particular because of the audience, obviously, but we have found in our US partner a very willing partner. Perhaps because also we put things on the table. We think that to be able to build these agreements, you have to share the burden and have your own capabilities and bring data that you're willing to share. It shows that you're serious about it. And so we have mutually benefited from these agreements, and hopefully we hope that this cooperation will continue under the new US administration and obviously under also the soon to come new French administration. Thank you.
Very good. And Klaus?
Right, thank you. I'll try to then add some European points to what has already been said. Well, if I start where we are today, European Space Agency, and also since we have a joint space policy with the European Union, although we are two separate organizations, today we are, I would say, grateful and relying very much on US data as well, and a bilateral agreement with the US Department of Defense to do collision avoidance maneuvers and get data for the safety of our systems. If I look at SSA and space traffic management, there was a joint statement, as I said, between ESA and the European Union in October last year. And we decided on 3 strategic goals for European space policy. One of them, of interest to this discussion, is that one of the goals is European autonomy in accessing space. It's been there forever, but now also with the addition, using space in a safe and secure environment. And using space in a safe and secure environment then translates down to concrete actions from ESA member states and from the European Union. And one of them is to build up a robust SSA program with the 3 elements: normal space, surveillance and tracking, space weather, and also observance on NEO objects. Interesting enough, one concrete task from member states is to ensure the resilience of our space systems in Europe. So I've heard lots of talk about resilience here today in the American debate, and this is a task from member states on the European Space Agency to improve the resilience. And I believe the simplest way to do that in many cases is maybe then to find reciprocal agreements with allies and partners. So that there is a willingness to discuss this in Europe as well. When it comes to SSA program, I won't go too much into the technical details. I was a deck officer in the Navy. I always avoided technical issues, so I'll try to avoid being too technical today. But it's clear, if you look at the European Space Agency and call it civilian SSA in Europe, we are relying on the armed forces in our member states and access to data from our member states, from Germany, from France, from Spain. Spain also has a nascent SSA program. We have put in place agreements to be able to exchange classified data, but obviously we're talking about the most sensitive military systems in our member states. So obviously there's a question always of need to know, or a lack of need to know. And there's a need to filter data and to put in place concrete dissemination policies. This is still work which is ongoing, because everything which has to do with coordination of national security assets in Europe takes time. The time has to be mature, and it has to be the right political climate. And this affects SSA very much, I would say, at the very basis. So things are not always moving as fast as one would like in building up our own assets in the SSA area. If I jump to another concrete task from the member states, space traffic management, or rather the task is that they put a supporting role in ESA to help member states or assist member states in legislating on space issues, to create space legislation. If you look at the map of Europe, you have a couple of member states that have their national space legislation. Others don't. Others have come to realize they need one. So we now actually have a concrete task to support member states that ask for help to enact space legislation to do that. And it's interesting that the word international space traffic management is mentioned in that task. So it's clear that there is a view, consensus view in the member states of the European Space Agency, that we should develop rules of the road for space traffic management. Finally, I note that we also have a task to improve the understanding of space security risks and dependencies. And I suppose that's why I'm here today. That's one of the reasons.
Very good. So I think one of the things that occurs in early discussions of space traffic management and even of SSA, there is often maybe a simplistic picture of that there would be some master control station. That everything would be, one single organization that could be the definitive. And we occasionally see proposals like this from our Russian colleagues, for a single international system. Yet the reality is the commercial community and different countries are each bringing different data to bear and different purposes. So this leads to the proliferation of multiple catalogs. And so in that environment of multiple different data sources, not one single authoritative source, maybe should there be a single authoritative source? Is that a hopeless goal? Are we going to simply deal with multiple catalogs? What do you see happening as more and more different sources of SSA data are out there? I'm looking at the commercial guy.
Okay. Take first a bat at that. It may not be well known today, even within the U.S. government, U.S. Air Force. There's more than one catalog today, and it's being managed to date very well. It is not a technical challenge to manage multiple catalogs. There are capabilities, technologies that allow multiple data sources to be brought into a single catalog as well. Certainly our capability allows and supports that, but there may be also parallels in other domains, like the aviation domain. We have the FAA. There are other organizations in other parts of the world that fly and operate using their own databases, but they're able to talk and communicate and share information. So I would suggest that capability, their technology exists today to allow that to happen in the event that there are multiple catalogs.
Just to reinforce what Travis said, yes, I think it's a difficult goal to pursue, to have one perfect catalog. And already, as again Travis said, there are many. But the idea that there would be potentially a government-managed catalog that is as good as can be because it is able to deal with a lot more sources and able to resolve conflicts, and then potentially is available for free for the community to use. I mean, it's not the only way forward, but that's certainly one option we heard as we did our research, and it could help the research community to better understand the space environment. I think one of the things we learned in our study was we really don't know how good these government or private sensors are. I mean, we heard constantly, private capabilities are exceeding government ones. That sounds really good, but I haven't seen a paper, even in a classified domain, that kind of demonstrates that. So I think having something that is available for, to the extent, they are classified things, obviously some things would have to be removed from the catalog, but to the extent that's possible, it would be good to have. And then, if there are multiple catalogs, they coordinate, they learn from each other, and it's like having, we can't destroy all clocks. We all have different clocks, and we kind of say, well, what time do you got?
So is there for our international panelists, is there a requirement for national sovereignty to have a national catalog that's separate and distinct from what might exist in the international community?
Well, I think what we need, the national sovereignty issue always associated with the national secrecies that you want to operate the satellite which don't want to be disclosed. And I think we need to make this certain compromise between the transparency and efficiency of the catalog and the national sovereignty, or the necessity to be to not to disclose the information that is important for the national sovereignty. So I think what is important is to make sure that each catalog exists and in a way that people can talk and try to understand each other, that whether these non-listed objects may not be create any sort of harms. And I think this is the basis of the space traffic management in the future.
I would say it's hard to envision a single unique catalog for everybody. I mean, as long as you have national security space assets that you would like to protect, you may want to retain some level of secrecy about where your space assets are. So, yeah, being able to share data among willing partners is a good thing, whether they come from different catalogs. As long as we have agreements to share them, that's fine. But also being able to retain some secrecy and also making sure that other allies understand that we have to maybe protect each other's national security assets and not disclose their existence through our respective catalogs. That's probably more the debate that we need to have now.
Right, and it's not just national security assets that need to be protected. I mean, private companies want their maneuver capabilities protected. I mean, it's proprietary information for them, so it's part.
Well, and I use the term catalog as somewhat itself maybe a prejudicial term, because SSA is certainly more than a catalog. It's about, as you were saying, understanding what those little white dots actually are and what they do. And that's probably even the more for their own sovereignty. Do other countries have that same standard? Do they aspire to that? Could they afford that? Are they willing to rely on others? So that issue of how much you need to know for SSA to meet your national interests.
Well, I think there has to be some sort of a layer of or degrees of the a disclosure of the information. If that is only shared with multiple layers of the way to handle the information about so the catalog is not just a simple one, but there are catalogs for alliance, catalog for general public, or catalog for some friendlies and not fours, or something like that. I mean, there should be a sort of a multi-catalog, although it is a sort of a simple same database, but you can have a different degree of disclosure. And also, I think about the interpretation of intent is more important than just sharing a catalog. So I think the dialogue among the allies is an extremely important exercise to make sure that we are on the same page to understand the behavior of the other white flips.
I think, again, if you look at Europe, national sovereignty is sometimes a complicated subject, especially if you look today when we have developed at the European Union level at least one, arguably two, satellite systems, which are sort of a joint property between the European Union member states. So for the time being, we would like to believe that Galileo is a civilian system under civilian control. I'm not sure everybody else around the world would look at a global satellite navigation system the same way. It is a strategic asset. And I think we need to understand what are the potential security threats to such an asset in certain situations, and how does one respond to those threats that might exist. And then you're no longer at the national level, but you're at EU level. François Rivasseau is not here today, but he is, of course, head of space policy in the European External Action Service. So he would probably be a better place to ponder a bit more on that. But there is an aspect which goes a bit beyond also the sovereignty of member states sometimes.
Yeah, I like this idea of several layers or levels of details in the catalogs that we have. I mean, if you're a private company launching satellites, maybe just knowing the position of the white dots is enough for you. I mean, what you want is basically deconfliction with debris and other satellites. That fits your need. If you're a Ministry of Defense and you have space assets, you're more concerned about what's going around your space assets and what exactly these white dots around your assets are doing. Are they capable of moving? And if you see one popping up, suddenly launch from Earth and moving close to satellites. What is it exactly? So you need to understand more about the details and the capabilities and the intent also of the one that sent it. So it's there's a space surveillance aspect to it, but there's also classic intelligence going on about the intent of your potential adversaries. So having several catalogs, I mean, that differentiate depending on the level of details that we provide, and also how you can share them is something that can work.
So the requirements for security probably being more demanding of information than the requirements for safety and collision avoidance, which probably can find more common ground with. Let me take an opportunity to open it up for questions from the audience. And I see Victoria over here has her hands up first.
Thanks. Victoria Stamps, World Foundation. One thing I'd be curious to hear from the panel is how SSA going to change in the face of the coming mega constellations. As we know, the FTC filings recently, there were 16,000 satellites that in theory could come online. Obviously, not all of them will, but even if a small percentage of that comes on, it's going to majorly change how SSA needs to function. How do we face this challenge?
I would maybe offer that automation is going to be a significant part of having systems that can automate what is being done today. I know our operations center last year, some of the nominal numbers that we've seen, over 1,500 maneuvers detected over a 30-day time span, over 1 million observations on a monthly basis. With the number of satellites that will be in space, the accuracies that are needed to assess when a satellite needs to maneuver and not maneuver, and the ability to track much smaller objects. It's been determined objects or debris greater than 2 centimeters in size could cause catastrophic damage to these smaller satellites. And so being able to automate the types of analysis and assessments that are done today to where an operator is alerted to something versus an operator performing analysis, in many cases manual analysis. So I'd really highlight automation as a big one.
Scott, can I add something to
Please.
that? So I think that is one of the strongest cases one could make to have more of a civil-led SSA system. So you can actually address some of those issues. And I think one important issue with the constellation isn't congestion. It's not that there's that many satellites, as somebody said this morning, space is pretty big, but it's an issue of accuracy. We really need to get better with respect to how well we do our conjunction analyses. One of the things we learned in our operator survey, which we talked to a lot of the satellite operators, both the LEO ones as well as the GEO ones, and they would like to have sensor tasking. Right now, they cannot, ask a DoD as a sensor, hey, go look at my satellite and where the secondary is. And that would be another case for, maybe a civil agency working with a private entity like LEO Labs or Exo Analytics or AGI or others to be able to do some of that secondary tasking.
Okay. So a question, Teresa?
Hi, I'm Teresa Hitchens with the Center for International and Security Studies at the University of Maryland, and I want to thank the panel for a very interesting set of presentations. I have a question about the improvement in technology for actually observing objects in space, and whether or not that actually makes it easier to share information, since so much information is actually available to the public if they know what they're doing and they have a really good telescope. And it seems to me that that mitigates against such a high need for secrecy, so doesn't that make sharing easier?
I'd say it may not be the technology that makes sharing easier. In most cases, it's the source of the information that may make sharing easier. National security systems or military systems, it's challenged to share that information, though the alliances help make that happen. I know General Kaler's time at US Stratcom started the combined space operations concept and has matured quite a bit, including nations like France, Germany, and Japan. So alliances can share information because they have those sharing agreements. The one advantage that commercial SSA providers lend to being able to share information is the ability to attribute and provide that information, because the sources and methods are not classified or national sovereignty. It's another parallel would be the commercial imagery providers. They're able to share information to just about anyone, but they also service the national security space systems. So I would suggest that commercial systems and providers really provide the ability to really share information across the board.
Just let me add, I think the improvement of technology may provide more accuracy, and the accuracy would certainly support and help the operation and operators of the satellites. But the question is about how to interpret the intent, and that is something that you cannot do only by improving the monitoring technology. So it also needs to associate with other kinds of intelligence, and I think this is where the issues of the military secrecies and all the other things that we discussed comes into. So I think, improvement of technology would provide more safety, but not security, to put it in that way. There's a question there?
Hi, Scott, thanks for a good panel. I'm Meade Treadwell, a former lieutenant governor in Alaska, but I also have headed several technology firms over the years. We started campaigning for AIS for ships in the 1990s after the Brer incident, which was an oil spill off Norway and off the Shetland Islands. And it really took us until 9/11 until we adopted AIS for most of the world's ships. But today, we know where all the ships are off our coast that have positive intent. Negative intent, we're not sure. We developed ADS-B, the Next Generation Air Traffic Control. First operational place was in Alaska. And we are now taking that live on the Iridium satellites going up with Aeron. I chair the Iridium Polar Advisory Board. And I guess the question is, can we do the same kind of agreement on every new satellite going up, that we have either something in the timing signal, because they all have some radio signal, that gives us a location capability that's more exact, that would be a simple enough international agreement to make these cataloging issues go away for all of the positive satellites with intent. And if you have a satellite that's negative intent, you've probably told the world about it one way or the other anyway. And it might solve a lot of these problems.
I guess I'll take a moderator privilege and maybe grab some of it first. There's a lot of different ways that these owner-operators could make life easier for the SSA folks. I mean, things to, deorbit sooner, put corner reflectors on and transmit a signal. When Planet Labs did the 98 satellites out of 104 coming off, they provided information cooperatively to the U.S. government to say, here's where our objects are, so it wasn't an attempt to hide anything. So there's a lot of things that would be good practice. And the question I would have for industry is, where do these things make sense, and when can they emerge as common best practices, the way we had best practices emerge for orbital debris mitigation that were later codified into international guidelines and were later codified into regulation and licensing requirements that flowed from voluntary guidelines. I'd be very nervous about trying to do a top-down approach. There is no ICAO for space, and I would argue there probably shouldn't be, but that's another issue. But I'm interested, I would hate to have a one-size-fits-all, so you point out very possible solutions. The question then is, what's the process by which those solutions should come forward, and how do we make sure we're not too early but not too late in putting them in? Because once we start talking about licensing and requirements, and all kinds of other bells will go off. But
I think in addition to that, in case of AIS, I mean, There is no obligation for the smaller vessels to carry the AIS, and then you still need to do the monitoring. I think that's the same thing for the space situational awareness. You need to monitor the debris which doesn't emit any signals, or which doesn't associate with the operator's responsibility. So yes, for the best practice of the operator is one thing, but the monitoring of the space situation is another. So we still need to avoid the hazardous material. Hazardous debris. And then in order to avoid, we need to have a catalog of those objects in orbit.
Also to add, it's not just industry launching. Let's take CubeSats and small sats. You have high schools and universities, not just in the United States, but globally being launched. It's just a difficult thing to require, sort of to raise the cost of a university in Singapore or somewhere doing, launching for research reasons. So it's a nice vision to have, but it's difficult, at least in the short term.
But ESA is going to do something on its own?
We'll see. We had a discussion yesterday a bit on space traffic management. It's not exactly the same topic, but I believe if one aims for perfection, you will never arrive. But if you aim for something which is reasonably fit, you're more likely to succeed. I think one previous question was, what will happen with the mega constellations? And we spoke about technical solutions, but I believe it's inevitable that one looks also at the rules of the road, at the space traffic management rules. And if one focuses on just rules of the road, if one is not trying to solve non-proliferation issues and national security threats, there's a greater likelihood to succeed.
And so you mentioned ADS-B, and I started using it as a private pilot around DC here, and it changed my life, so I'm a big fan of it. And why not thinking about ADS-B like for space? But at the same time, as you said, what about the standards to build that capability? We'll need some kind of overarching organization to set standards for that. Because if everybody uses different frequencies, even for small beacons, if we use an AIS kind of capability, so we'll need some kind of standards, and who's going to set them? Do we need an ICAO-like space agency, worldwide space agency, to do that? Can we work it bottom up? I'm not so sure. And also, as you said, it raises the cost for small operators and very small sats. So I like to think it's a good idea. How to implement it in space seems that's where the analogy with the air breathing environment stops, I would say.
Yusuf Butt, State Department. I have a question directed, I think, to Bhavya or Travis regarding the future of space situational awareness and space traffic management. Basically, Victoria raised the issue of the larger constellations that are going to come online, and you mentioned there might be up to 10 times as many conjunction alerts as there are right now because of the larger number. There's a separate issue of the higher sensitivity detectors that will be available, like space fans. So that will, it can, again, I think the numbers are uncertain, but hundreds of thousands of extra things to track. And the resultant conjunctions, potential conjunction alerts for those extra tracked objects. So my question is the extra accuracy from the future detectors going to be able to partly or fully offset the larger numbers of potential conjunctions so that you're not overwhelmed with tons of conjunction alerts per day? Or is there a plan to handle this? And related to that, if we are in such a situation, you can envision that you might be checkmated where you might say move in the Z direction, and then you're in a new conjunction with a small piece of debris that you're tracking due to your higher sensitivity. So is there thinking on that, or what's the thought to address that issue?
Travis, do you want to take it?
Yes, from our vantage point, it goes back to the accuracy of the processing. You know, from the ComSpoc perspective, more data is great. The technology that we implement is able to filter out bad data. So, and we've also simulated, and there are models out there from NASA and ESA of 200, 300 objects in space. Again, not a technical challenge whatsoever. We've been using those models and preparing our systems to handle those large catalog sizes and performing the appropriate conjunctions, including the ones, if you maneuver in this direction, making sure you don't put yourself into another conjunction. So from my vantage point, it's not a technical challenge.
I think I would add in here that, you know, space is still really big. And as we have these objects are still really small, so the cross sections are still small. The problem is the uncertainty, and going to the accuracy point. So we have these error bubbles, you know, around these objects, and the error bubbles collide with each other, and depending on the rules you have, you generate very large amounts of false positives, which make people start to ignore the noise. They turn the alarm off. So the data processing, the accuracy is absolutely part of it. This may be maybe too Pollyannish, but if I look at the mega constellations, which on one hand I think are a very serious issue, on the other hand, it's also sparking the introduction of counters. So somebody like Leo Labs putting up potentially a commercial but a radar-based system. I never would have thought that would even, you know, be a feasible thing. But we're seeing people coming forward with solutions because if they can avoid maneuvers, they provide an economic benefit that, you know, might justify a certain amount of spending on the commercial side. So new solutions start to come to the market. The problem that's not dealt with is that states are ultimately still responsible. States still have liability for these things going on. So we have all these wonderful international commercial things going on, and they're bringing these new solutions. But at the end of the day, states are still responsible for these entities. And so what liability are states willing to absorb? To what extent are they willing to rely on other systems? How much can they rely on that without basically putting their sovereignty basically in trust to these other systems? Those aren't questions that I think the commercial guys can answer. Those are questions that the policymakers need to decide what responsibilities they're willing to take, what they're willing to outsource, and what risks they're willing to absorb. Sorry, long answer.
And also, if I could just add one sort of a tangential element to it. So I think a collision isn't a question of if, when, but when. I mean, eventually there will be collisions, but I think, remember, this industry is growing. I mean, now there are companies that are wanting to do debris mitigation and debris removal. I mean, there's US companies like Tethers Unlimited developing new technologies. There's a Japanese company, Astroscale. There's an Israeli company, Effective Space Solutions. So, you know, so obviously nobody wants a collision, and the quality of our accuracy is going up and will continue to go up, especially as we bring new innovative approaches. But I think we will find ways to, you know, get rid of the debris. It's not an unsolvable problem.
It wasn't a question about the actual debris, it's about the sensitivity to the existing debris, so that you're
Sure.
sensitive to a lot more things that that are there right now, but we're just blissfully ignorant.
Understood. Yeah.
Good.
Yeah, if I could add on that, there are some of the studies we've been doing looking at the future. If we start looking at catalogs, objects in the catalog or objects in space that are smaller than 2 centimeters, the current public catalog, at least in GEO, is only actively tracking an estimated about 4% of what's actually in space. And it's roughly maybe 5 to 7% in LEO if you get down to 2 centimeter size.
So we have time for one more question. Joseph?
Thank you. Thank you for putting this interesting panel together. I have a question. It's rare to actually have this opportunity for commercial and international, get a perspective on that. So my question to the panel is should the advisory role of providing space traffic messaging services, should that always remain a government role with a providing some services free for some who can't afford it? Or should we, or is there room for eventually a purely private model where it's a fee for service? And the analogy that I'd like to use here is the air traffic control US versus European model, where US it's pure government role versus the European model is a more fee for service role. So I'd like to hear the commercial and the international view of, should it remain a government function or should it become a private function?
I'll start. At least here in the U.S., there's, again, with the dynamic situation in space from a national security perspective, it's been stated by the senior leadership in the Air Force that the space traffic management is inherently non-military, and the resources that are being used for space traffic management could be better utilized for the inherently military purposes. So given that there is a need to better leverage those national security resources, and that there is a growing demand for commercial or at least space traffic management services that are not military, I would offer that the commercial services, fee for service, provides an opportunity to deliver those services with the needed accuracy, with the needed capabilities that commercial can provide. Should there be any government oversight or regulation, there probably is a role for some type of light oversight. What happens if there's an adjudication situation that needs to take place? So perhaps there's some role there. There's also could be a role in certifying the providers of commercial space traffic management services. Bhavya mentioned there's a list of, I think you said 30 or so in your survey, but how many of those could be certified to provide these types of services? In the military world, it's called technology readiness. How many of them are at the operational state that could actually satisfy that service, and going through the validations like on the international commercial resupply commercial services. So I would say that there is potentially a role for certifying providers, adjudicating situations that may not be able to be adjudicated between commercial providers and users of the service. But I would offer that it should be very light, small on the oversight.
Well, I may have a different point of view, but let's think about a very practical example. Awarness is launching commercial satellites from spaceports in Guyana, in French Guyana. So it's a private company launching private or commercial satellites. Why my government should be involved? Well, even if Awarness relies solely on a commercial provider for SSA, as long as we have, as a French MOD, capabilities and access to catalogs, I'm pretty sure we will run our models to make sure that the rocket trajectory will not interfere, and the orbits will not interfere to known debris or objects. So, and if we don't, and if something happens, our government will be in big trouble, I would guess, for not having provided that kind of alert. So I'm not saying it should be only government. If it's a service that can be provided by private companies, fine, but I'm sure that there will be some monitoring in the back by our government to make sure that the launch happens and is safe.
If you take the analogy of the air traffic management, in Japan, there are, even though the airports are privatized, the air traffic management is still the government responsibility. And we do have a very funny airspace control, because on the one hand, you have the civilian airspace control, and then you have the Japanese military's airspace control, and then you have the American airspace control over Japan, because there are a number of American Air Force bases. So if it's involved in the international coordination and the civil military coordination, it is getting extremely complicated if you are trying to let the private industry to handle this sort of a situation. And I think at the end of the day, the government is ultimately responsible for the protection of the assets. And I think as long as the government recognizes that importance of the role of government in space, I think it is reasonable for the government to maintain its to involve certain role. Although there are possibilities that there are some value-added services can be provided by the commercial entities, but the core basic issues needs to be handled by the government.
I'll reiterate something I said earlier. What if I'm a 3U CubeSat operator and I have no interest in purchasing the service because my satellite's only going to be up there 3 months? I'll get what I need out of it, and I don't really care to pay money to see where my assets are. So.
And so these questions of information are not just unique to SSA, but questions about what should be an inherently governmental function, what can be outsourced, how does the government follow its stewardship for the public safety and security, yet at the same time do it by minimizing the amount of taxpayer resources and leverage that. So it's kind of a common theme we've heard, not just here, but of course in launch and commercial remote sensing and other areas of space that don't fit neatly into particular silos. The characteristic that we keep seeing is that these issues blend across the civil, commercial, and international sides in ways that make it fun for discussions like this. But with that, I think we're out of time. And I'd like to thank the panel for their interventions.